Sir, good morning.
Hello, sir. Good morning. Very good morning to you.
Sir, please try to share the presentation, sir.
Okay, sure. Yes.
Yes, sir.
Yeah. Is it now visible?
Yes, sir.
Okay. Thank you.
Thank you, sir.
Dr. Uttam Kumar, good morning.
Good morning, sir. A very good morning to you.
How are you, sir?
Yeah, I'm fine. Thank you. Thank you, sir.
Yeah, thank you very much for again accepting our invitation.
Definitely,
We
sir.
are
It
very
is my
privileged
privilege.
to have you in
Yeah,
our workshop.
it is my honor to be invited again and again by you.
We will be inviting again and again because we have a good training center now.
Definitely, sir.
Offline physical
Definitely.
trainings also will be conducting, Doctor. We'll
Okay.
be
Okay.
inviting you.
Yes, sir. Definitely. Thank you so
Shall we
much.
start,
Thank you.
Doctor, now?
Yeah. Yeah. Yes. Please.
Yeah. Good morning, participants. We have with us very distinguished speaker from IITB, the very prestigious institution in Bangalore. Dr. Uttam Kumar is the professor in IIT Bangalore. On behalf of all of you, hearty welcome to the speaker, Dr. Uttam Kumar. Welcome, Doctor. Now, let me have the privilege of briefly giving an overview of his accomplishments. Dr. Uttam Kumar holds a bachelor's degree in computer science from VTU Belgaum, then diploma in advanced computing from CDAC Pune, then master's in geoinformatics from University of Twente in the Netherlands, and PhD in algorithms for geospatial data analysis from the most prestigious Indian Institute of Science. He has worked as a project assistant, then a research associate at IISc, and he moved to NASA for a postdoctoral fellowship. Then he earned his professional certification in data science and machine learning from the most prestigious Massachusetts Institute of Technology, in big data from Stanford University, in spatial computing from University of Minnesota, and in geospatial intelligence and revolution from Pennsylvania State University, USA. He has a very vast experience, and he has visited many renowned institutes, and he has been trained in those institutes. Dr. Uttam Kumar has published more than 50 research papers, both in national and international journals of repute, and also has presented in conferences across the globe. And he has also authored 8 technical reports. He has delivered many invited guest lectures. Many times he has accepted our invitation. Very kind of you, Doctor. And he has received several awards. Institute of Engineers India Young Engineers Award in 2016, NASA Group Achievement Award by NASA, in then Certified Sentinel of Science Award in 2016 in Earth and Planetary Science, Best Paper Award in 2015, International Conference on Machine Learning and Data Analysis, UC Berkeley, Best Paper Award in 2015 in International Conference on Remote Sensing and Applications, Los Angeles. So he has many more awards to his credit. His research interests include data mining, data science, applied machine learning, remote sensing, digital image processing, management information system, large-scale geospatial data analysis, and free and open source softwares. He has published many papers and book chapters in many conferences, as I told. With this brief background, let me have the privilege of welcoming Dr. Uttam Kumar to deliver his talk on machine learning in our this workshop on recent advances and career opportunities in engineering and technology. Over to you, Doctor, for your talk.
Thank you, Dr. Ramesh. Thank you so much for inviting me, and I'm actually honored again and again by your invitation. So I am really grateful to you for remembering me in all times. And good morning, all of you, all the audience. And I welcome you to the program and to my 1 hour session. So as you have already seen, I work in the area of remote sensing and machine learning and do more of data analysis. So uh, much of my data comes from numerous satellites, and the broader picture is
Doctor,
actually
excuse me, we are not able to see you.
okay. I have switched off the
Oh, I see.
camera.
Okay, video.
Yeah,
Okay.
yeah. So So the broader picture is termed as GIS. You might have heard this term many times. It's called Geographic Information System, and all the other areas where I work essentially focuses on different aspects of problem solving in GIS. So as such, most of the images or data that I work on are obtained from or procured from based on satellites. Therefore, since these are images, lot of image processing techniques are used to process them. And and recently, with the advent of new machine learning algorithms and deep learning, etc., are being currently used to process these data sets. Apart from this, when you have to handle large amounts of data, we typically need some kind of database systems where you can store and retrieve those information. And in today's talk, what I will do is take you through each of these topics very briefly, and then finally show you some possible case studies. So the idea is that machine learning is so broad that there are numerous applications possible, and one of the applications in which I and my group happens to work, which is the GIS. Okay. So most of the tools and softwares that we use are free and open source software, and we try to write codes and promote open source technology. Although there are a lot of open source softwares already available, so in the process of writing codes, people understand the technology better. They are able to appreciate the methods, the algorithms better. So FOSS is a great way to promote research in machine learning, in GIS, and so on. So I will take you through each of the subtopics, and then we will try to see where all you can use this kind of information, and where all actually I have not listed. I think I just forgot. There are lots of jobs and lots of companies currently working in this area. I will try to highlight that at the end of my presentation. I have it in one of the other slides. I have not pasted here, so I will highlight that. Uh, but I think this time you may be already clear about what is AI, what is data science, and how it is different from computer science. In fact, there was a recently interview by interview with our director at IIT Bangalore, Professor S. Sadhugopan, and the interview was online through Times of India, and then some abstract interview points were published in Times of India. So a very common question is that are AI, artificial intelligence, data science, are different from computer science? Okay. So I have taken some points from his interview. I found it very interesting. And if some of you may not have seen his interview or have not read in the newspaper, we'll just reiterate now in a very summarized way. So AI, the term AI has become very popular. Very often you see people talking about AI. AI is actually artificial intelligence. So AI, analytics, data science are all part of computer science. Okay, so the basic computer science or the traditional computer science subject consists of computer hardware, okay, and then programming, then databases, etc. Okay, but much more important is to use it to process and analyze data. Okay, and then figuring out how to understand that data and how to draw insights and foresights. Okay, so in the field of AI and data analytics, there has been a revolution, okay, as all of us can witness. So computer science nowadays has moved away from the traditional methods of storing zeros and ones, bits and bytes. Okay, it's currently doing a lot of things in almost all areas of life. Okay, all of us use different applications. Facebook, for example, or Google Maps, for example, are all different applications of computer science. So it is also important that many of you might belong to bachelor's degree program, master's degree program, and research scholars, etc. So it is also very important to highlight that the underlying principle in computer science. Okay, so if you see computer science is actually a science. Okay, whereas it has been customized and tailored at universities to be called as computer science and engineering. Okay, so computer science is more of the basic ideas. I mean, the ideas that come from other mother branches, such as your mathematics. So, in fact, if you do more research in computer science, you will eventually see that computer science is more and more of mathematics. Okay, it comes from most of the concepts come from linear algebra, probability and statistics, calculus, etc. Okay, and therefore mathematics is very important. Okay, so data science or data analytics can do the things very fast, very fast. Okay, but in the process they also generate lot of output that may not be relevant to us. Okay, so we should be able to take the unwanted material or junk output, okay, and look at the essence, what is left, what is of relevance to us. So there is the role of data science or data mining. Okay, so mathematics helps us to model scenarios, and in fact I would say that computer science is actually mathematical science. If you happen to see some of the best papers published, it is actually mathematical science. So it is really important to have good understanding of mathematics, especially in the area of machine learning. Okay, mathematics is very important. You may read in several, several forums, the use of mathematics, the different branches of maths that are that have application in machine learning. Okay, so therefore now it is really good to have a strong mathematical background in order to excel in this field and in order to understand the fundamentals of data science and machine learning. Okay, so I will quickly go through some of these terms and then relate it to how machine learning is used. So all of us know that we live in two types of world. One is a natural world, which was given to us as a gift by our elders, by our forefathers, and that was self-regulating in the sense everything in the ecosystem was self-maintained. You had forest, vegetation, rainfall, and a nice temperature and clean water to drink, and so on. Now, with human involvement and the way we are trying to manage the world, okay, we have actually brought a lot of changes on the earth. Okay, all of us witness in day-to-day life, maybe building construction, to dam construction, to road construction. So we have, in some sense, disturbed the underlying ecosystem. Okay, so in the process of managing the self-regulating world, we are increasingly in conflict with the natural world. Okay, so there are two aspects. One is context, other is content. Now, many of us, while taking decisions, for example, trying to build a real estate building or trying to do something in a city, we look at a very small area. Maybe we may be looking at a neighborhood, or we may be looking at communities or districts, and then we take decisions based on this kind of bounded systems. But more often, all the decisions taken at very low level, uh, they impact global phenomena. For example, when you see that there is ice melting in North Pole, okay, the sea level rise is also witnessed in most part of the world. Even though it happened at a point, it has impacted most locations around the world. Similarly, any other phenomena like global warming. So all these phenomena which happens not to be local but global, they have patterns, they have linkages, they have some trends. Okay, and these trends are often witnessed when you do some large scale analysis. Okay, so GIS is actually one tool that allows you to analyze data from local to global level. Okay, what is GIS? It is actually a software. Okay, software, hardware, and personnel. Personnel in the sense people who work on GIS. Okay, and GIS allows you to link geographic information, that is where things are, with description, with attribute, what things are. So in a GIS platform, you have the luxury to represent each layer of the earth in different themes. These are called thematic layers. As such, you see customers, buildings, etc., and streets and so on are different themes that capture the reality of the world. So these themes are layers of information, and GIS allows you to digitally represent this information on your screen in the database. You have the freedom to overlay one layer above the other and then do analysis, and then drill down across the layer and do lots and derive lots of information that are relevant for policy makers or taking any decision. So GIS actually helps us to answer a lot of questions. For example, what exists at a particular location? Okay, so in terms of earth science, particular location is a latitude longitude. Is a particular location is characterized by a latitude longitude. Okay, where is it? Second question could be where is it? So this question can also be in the context of a condition. Okay, which location satisfies certain condition? For example, if you are the head of a communication service provider, for example, Geo or Airtel or any other such provider, and you have been given the responsibility mount communication towers in different parts of the city. So you have to take a decision. So your decision may be based on certain conditions. For example, how many subscribers are in a given area? What is the population density? Is there already existing communication tower in that area, and so on. Okay. These kind of conditions can be analyzed simultaneously to derive at a decision. Then trendy question. So trendy question allows you to look at a trend, look at a phenomena with respect to time. That is, handle time series data and see how things have changed over a period of time. Okay. So as an example, the city of Bangalore has changed a lot from in the last 20 to 30 years. Okay. One can ask, how has it changed? It's a trendy question. Okay, which data are related? Now, this is something where you are trying to see the relationship between two data or two objects or two phenomena. Okay, for example, a very simple example could be road and a car are related. Ship, water and boat are related. Water and ship are related. So there are many objects that are correlated to each other, but we may not be able to make out until we actually mine the data, until we actually see this phenomena from the data. Okay, and the last one is really very important. What if? So what if helps us to analyze scenarios, in cases, analyze scenarios in cases what will happen if you change something in the real world. Okay, what will happen if suddenly you get up and see that the road in front of your house doesn't exist, but a canal has been built? Okay, so likewise, you can think of many scenarios. Definitely, the scenarios should be realistic in nature, and and but you do not want to actually uh, take an action and then analyze. For example, you do not actually want to spend millions of rupees and construct a dam and then see the consequence of a dam on the nearby area. Rather, you would try to simulate a scenario and then see what are the adverse effects of having a dam in a given area, how much area will be submerged, and so on, and then take a decision whether it is really useful to construct a dam or not. Okay, so model allows you to generate alternate scenarios based on the weightage given to the different parameters. Okay, all these sort of questions can be answered in GIS. Okay, now having given a brief introduction to what is GIS, let's see what are the data sets used in spatial data in GIS. So these data are spatial data, and in GIS, the spatial data are represented by a point having a comma y, okay, and an attribute. Any location will be identified or represented by a point x comma y and an attribute attached to that. Okay, so it may look very simple, but it can slowly become too large. Okay, imagine there are millions and millions of points in a city. You move meters or 1 meter ahead, your latitude longitude changes. Okay, and every new latitude longitude may represent a different feature. For example, one location x comma y will show ATM machine. Second location may show a restaurant. Third location may show a bus stand, and so on. Now there are infinite, actually infinite number of points in a given area. Therefore, you have so much of data. Okay, so spatial database is a new emerging area where uh, technologies related to how to store big data, how to retrieve information, how to do queries, how to do updation, etc. are possible. Okay, so when we talk about entire GIS, then the sources of data are many. You have maps taken from Survey of India, or you can download it from the internet, or you can create your own map. Okay, then you have database. So as I told in the previous slide, database could be a collection of points and then attributes related to those points. It may also be reports, publications such as socioeconomic data, statistical data, census data from Census of India, and so on. Then a bigger source of data is remote sensing and aerial photography. So with the advent of numerous satellites launched into the space from different countries, there are now many satellites providing images of the Earth all 24 hours. Okay, and I have not put an estimate, but just to give you an idea, uh, every 2 seconds NASA generates 10 GB of photographs from on the entire Earth, and therefore currently data the data required for large scale studies such as climate change, etc., uh, they tend to be of the order of several petabytes, not terabytes, petabytes. So climate data, for example, is in the range of 30 petabytes. Okay. Next is a GPS. GPS, all of us know, is a global positioning system. So GPS not only helps you to know your location, but also helps you to know various other various other functionalities. We will see it later. Then, currently, laser scanners and radar have become very useful and are slowly becoming popular. And then, apart from that, you can also go and collect data on your own, maybe through a survey or maybe through a questionnaire, and so on. All these are different types of data that are utilized in this kind of in GIS applications, or um, or when trying to solve any problem. So there are numerous challenges when we try to handle this kind of data. I will show it later on. Okay, so remote sensing data, among the remote sensing data, currently there is a large repository of remotely sensed images, also aerial photographs. Aerial photographs are now a bit limited because of the cost issue involved in them. Okay, but the new recent trend is UAV images. So UAV stands for unmanned aerial vehicle images. You would see, or popularly known as drones, you would see that they are now becoming very popular in lot of studies. Okay. So many of you may already know that when we talk about raster data is essentially an image. An image is made up of grid. Each grid represents a pixel. A pixel is actually a picture element, and every pixel has a location and a value. This value is called the gray level, or intensity. And this pixel also has a number associated with that, the intensity value, or we also call it the digital number. Okay, whereas vector data are made up of line, points, and polygon. Okay, line can represent a road, a railway line, etc. Point can represent a city. So depending on the scale, point can represent a city in map of India, and a point can represent a ATM in a map of a locality. Polygons are lines joined together, and they are bounded by straight or curvilinear lines. And polygons represent features that have shapes, for example, a building, a lake, and so on. And, these features, represented by line, point, and polygons, may also have attributes. Attributes, for example, length of a road, width of a road, number of lanes in the road, the area covered by a building, the number of floors, and so on. There could be numerous attributes that can be captured for a given object or phenomena and are stored in the form of a database. Okay, may already have used some of the databases, for example, MySQL, PostgreSQL, PostSQL, and so on, PostGRES, and so on. Okay, so spatial database is currently one of the emerging areas. So spatial database is slightly different from the traditional database, because apart from storing normal data, and that is integer, real, character, etc., you additionally have location of every data point. And nowadays we also have images and videos as part of the database. So spatial database allows you to perform all the common operations done by a database, such as sorting, deleting, editing, select, manipulate, input, output, reformatting, and so on. And then they are supported by some kind of a query language, for example, SQL. Okay. Apart from that, they may also have a metadata, okay, or description or content of the database. So as an example, how is database used in GIS? Okay, so you can see that you have a global map here of the entire world. Okay, and there are several records for each country or region. These records are maintained in a table. Okay, and when you click a tuple row, okay, corresponding to this region selected. So maybe this row is giving you some information about Australia. Okay. On the other hand, you can do the other way. You select an area, and based on this area, you get the details here in your database. Okay. So a park is selected. Then you see is the park, how big is the park, what is the opening time, closing time, and so on. Okay, so these are all done through connectivity to the database, where you not only select the record, but you have the freedom to even select a feature, and then get the details of the feature. There are many softwares which have this functionality. QGIS is a software that allows you to store data, attributes, and then perform these kind of queries. Actually, when you I will show you later that when you do small queries like show me the restaurants near me. Okay, so you get to see locations of all restaurants close to you. Okay, the query can be even fine tuned. Show me all the Italian restaurants. Okay, so then the query is more refined. So you don't actually have to write queries to do this, because these are all inbuilt. But as a product, as a result of the query, what you see is all the Italian restaurants near you. Okay, this is the logic used. You have a database behind, and based on your query in Google, the underlying database is scanned. Okay, so spatial database deals with all the storage of spatial data, and how do you speed up your query through indexing. Okay, how do you process the query, and how do you retrieve information and then show the information. All those concepts of databases, concurrency control, and then indexing, etc., they are part of spatial databases. Okay. Now, a lot of developments have taken place in representing maps. I'm sure many of us, including me, have seen simple maps that used to be part of Indian Railways timetable. So currently, I don't know whether many of us use, but 10 years back, when Indian Railways was not available online, people used to go to railway stations to book their tickets. So I remember even I have used such Indian Railways timetable. We used to locate the source station, the destination station, and then used to find out which trains go in that on that line, and then based on that we used to fill a form and go to railway station and buy tickets. So in the process, in order to see where we are moving, how we are going, what are the connecting routes, there used to be attached a map, railway map. Okay, in the first few pages, and we used to open the map and then see from where we are going and is our destination, how long, long is the distance. Okay, so from that era, I'm not saying that we are too old now, but because a lot of this kind of developments in information technology has taken place, so we see a drastic change. Okay, so in that era, in that period, when the maps were published, they were very simple maps. Okay. Now, with the advent of technology, there has been a drastic improvement in the way maps are being published and shown. Okay, this is a simple map which many of us might have seen. Even in bus stands, we get such maps which shows us the bus number, the bus routes, and so on. And we have seen this kind of map in our high schools in 8th, 9th, in geography. Many of us have used these kind of maps in geography subject, trying to compute distance between 2 points through a string and so on. Now, see the kind of uh, development that has taken place in the field of 3D GIS. Okay, simple maps have become more interactive. Okay, these kind of maps now show you icons in the form of 3D objects, and then it looks a bit more interesting. I mean, people get interest to see and to locate things. For example, you can see some buildings with uh, some height attached to that, and buildings give us a feeling that okay, we are moving in certain direction, or we are able to locate something because of the similarity between what we see in the map and what we see in the real world. Okay. Great. Now, see the technological advancement. This is 3D output of a three-dimensional GIS. Look at the kind of buildings, their structures are so clearly visible. You can also see the marking on the roads, the cars, and so on. Now, Google has done excellent job in 3D GIS. No one even close to them. Look at the way they have moved away. They have moved in this direction. I'm showing you on the screen the city of San Francisco. Okay, and within the city of San Francisco, here is the Golden Gate Bridge, which is very popular. You can see the Golden Gate Bridge here. Okay, and here is Berkeley. So University of California, Berkeley is located here. It is one of the top universities in the world. Okay, and here is the San Francisco city. Within this city, this part is financial district, which happens to be a home for many offices and etc. And I have zoomed in the financial districts here. Okay, so what you can see here is the white lines are showing you the roads, and then each location has been between the intersection of each road there are blocks, and these blocks have buildings. Okay, so Google has been able to move from sky to the land. Okay, see this. This is now the satellite image for the same area. This shows you the buildings here. Okay, I have zoomed in further. Now you can see to some extent individual buildings. Okay, further zoom in, and now you see that your buildings are now visible in the form of 3D icons. Okay. So now you can actually do a relative comparison of the height of the building, and you can easily locate a certain building. Okay, moving on, you see that if you zoom further, you can actually see individual buildings, and see that financial district area is so packed, so packed by tall buildings. Okay, I have zoomed in one of the individual buildings, and you will be actually surprised to see that you can actually look at in one single window of the building. Okay, one single window of the building. There is so much clarity. And then moving on, now I am zooming in on the road. Okay, you can see cars parked. I zoom further. I have now landed on the road. Okay, you can see shops, you can see cars. And it is so much that you can actually even find out or even look at the details of the make and model of the car. See, for example, you can see the two cars moving next to each other. You can see individual moving on the road and so on. So message here is that is really really I mean, we should really appreciate the way um, Google has been able to integrate data from sky to land. Okay, initially they started with satellite images, then you zoomed in again and again, and probably after satellites they would have used drones, and then from drones they would have used sensors on the land. Okay, then I think they have taken images on the street, and therefore they are also called street view. Okay, so look at the precision. You keep zooming from the sky, and you land up on a road. And these data sets are so well arranged in terms of their coordinates, latitude, longitude, that that you can actually narrow down to a street level view from the sky. Okay, this is a this is the kind of a problem that Google has solved through data integration. Data integration is difficult because it ranges from satellite images to photographs. Okay, so remember, this is only one photograph, and for a city, they would have taken millions of photographs. The challenge is how do you integrate all these photographs from one level to another, and then create a database so that whenever a user moves his or her this finger on the mouse, right away there is a zoom on the screen and you land up on the street. Okay, and all the data sets have to be properly georeferenced, correlated to each other, nicely arranged in a pyramid layer from top to bottom, so that there is a data integration. Okay, now moving on to the area of remote sensing that I have been talking about, and essentially I highlighted that there are large number of satellites currently in the space that are providing us data most of the time. Okay, so remote sensing is very easy to understand. In fact, all of you currently watching the slides either on your laptop or on your desktop or in your mobile phone or in your tablet or iPad. Okay, so what you are doing essentially is you are doing you are remotely sensing the screen. Okay, and this is the process called remote sensing. So remote sensing can be called as a art of science. I mean, called can be named as a science or art of obtaining information about anything, about object, region, phenomena, etc., without without coming in contact with that phenomena. Okay, as I just told, all of us are remotely sensing our screen. This is the phenomena of remote sensing. Okay, so in principle, I'm going to show you a broader picture of how remote sensing works. So, um, sunlight from the sun passes through the atmosphere, hits various objects on the earth, for example, forest, water, grass, bare soil, wet soil, built up area, and so on. Then once it hits the object, some part of the light may be absorbed, some part of the light may be transmitted, and then some part of that light may be, or some part of the sunlight radiation might be reflected back to the atmosphere. Okay, so whatever light is reflected back to the atmosphere is then received by the sensors in the satellite. Okay, these sensors are not simple camera sensors that we have in our smartphone or in cameras, but they are uh, uh, TCD, charge coupled device. Okay, and these charge coupled device detect the amount of light radiated from the earth, converts these data. They have a to D converter, so they convert this analog data to digital format. Then these digital images are sent to the earth. Okay, this is how the overall process of remote sensing works. Now, remote sensing data is slightly different from the data that we capture from our mobile phone. In our mobile phone, you typically have a RGB image, whereas in your satellite image, apart from blue, green, red, you have multiple bands. You have bands in many other um, uh, spectrum, many other spectrum. For example, near infrared band, mid-infrared band, thermal infrared band, far infrared band, and so on. Okay, what is the utility? Why do we need all these bands? So you may have seen that near infrared cameras are used in night time. Okay, so in the night time when you have security cameras in homes or outdoor, when the lights are switched off, it's complete dark. Near infrared camera can still detect any movement in that area. It can show you who has moved or what object has moved. Okay, thermal infrared are very important to detect heat. Okay, any kind of studies where heat is involved. For example, heating of a city. Okay, you may witness certain part of a city are very hot, certain part of a city are cooler. Okay, so the areas near park or forest are cooler, whereas areas which are middle of the city with lot of buildings are hot. Okay, those can be detected using thermal bands. There are other examples like for as let's say if you want to study volcanoes, okay, or forest fire, so thermal infrared bands are very useful. Okay, this is a satellite image where you see Mansarovar Lake. Mansarovar Lake is located in Himalaya, and you see that it's clearly visible in the image. Uh, it appears like this because in the near infrared spectrum, water bodies absorb all the light. Okay, if they don't emit anything, if they don't radiate anything, if they don't reflect anything, it will appear black. Therefore, this is a near infrared image of that region where the two lakes, okay, and appear darker. Once you have the data, okay, once you have the data, numerous applications can be carried out. For example, land use, land cover change, feature extraction. So feature extraction is for all machine learning enthusiastic people who want to extract features. For example, you may want to extract roads, you may want to extract individual buildings, or you may be interested in extracting water bodies, lakes in a city. Okay, you can analyze patterns, you can do modeling, you can study growth of a city, you can study biodiversity, you can do large scale studies such as climate change and so on. Okay, so please remember that these are not the work of a geographer, but these are the job of a computer scientist. Okay, Facebook and Google are currently investing a lot of money in studying climate change. IBM has invested a lot of money in studying climate change. Okay, along with skills, along with expertise, will also invest a lot of money in building infrastructure. So simple laptop or desktop may not be sufficient. So organizations procure clusters of servers or huge computing power, use cloud, etc., and so on. Okay, now moving on. So the remote sensing data may be captured in different bits. Okay, different bits per pixel, and this is an example of an 8-bit image. Okay, so an image can look something like this. So every location on the earth will fall inside a grid, and that grid will represent one pixel, that pixel will have a value, and as a machine learning enthusiastic you will work on this value. If you have multiple bands in the image, you actually have a vector, right? So now from this vector you define a space, vector space, and now think of different classifiers that will be used to draw a decision boundary while separating two classes. For example, building and water. From this image, you have to derive two classes, building and water. So in the vector space, you have to draw a decision boundary, okay, something like a hyperplane that will divide the two classes. So it narrows down to a classification problem, classical classification problem. Okay, let's move ahead. So there is a term called resolution. Uh, I will spend 1 minute on this. Okay, higher the resolution, more clarity is there in the object. Okay, as such, you can see 4-meter data is slightly blurred, 1-meter data is more clear. Okay, so this clarity depends on the resolution, and this resolution is referred to as spatial resolution. Okay, on the other hand, the number of channels, the number of bands in electromagnetic spectrum in which you capture the data is called the spectral resolution. As such, in the previous slide, I had shown 6-7 bands, different used for different purposes. So I was referring to the spectral resolution. So spatial and spectral are two important resolutions that are often important in deciding what data uh, should be used to um, to complete a certain application. Okay, Here you can see a image of Greater Bangalore, and I'm showing here a zoomed version of an area. Okay, zoomed version of an area. This is the race course. Okay, and this is the lake, I think, near Lalbagh Garden. Okay, yeah, I know. I think this is Alsur Lake. Sorry, this is Alsur Lake. This one. Okay, and there are similarly other features. So this image is of 1 meter to by 1 meter resolution. This is 4 meter. This is 25 meter. This is 250 meter. Okay, so right away from the resolution, you can make out that higher resolution data are very useful in high level studies, whereas low resolution data such as these may be important if you want to do a study at country level or continent level or global level. Okay? Because of the computing power. This data at this resolution may be sufficient if you want to do study for entire India. I don't need 1 meter high resolution if I want to perform any analysis on the entire country. Okay. Whereas spectral resolution refers to the number of bands, number of channels. So you can see band 1, band 2, band 3, band 4. There are 4 bands. So I can say spectral resolution is 4. Okay. You can see different types of data. This is image obtained from Indian remote sensing satellite IRS-1C, 1D. AVIP stands for Advanced Wide Field Sensor. It is the data is of 180 meter resolution. It is mostly used for studying crops or plantation, agriculture farms, and so on. LIS3 data, LIS stands for Linear Imaging Self Scanner. The resolution is of 23.5 meter from Indian satellite. LIS4 MX, LIS4 is Linear Imaging Self Scanner. 4 is the version. MX is multispectral. It means you have more than one band. Resolution is 5.8 meter. So you can see here individual agriculture farms have been captured. There is some small settlement here, and then these areas are have greenery. Okay, so do not worry about the colors. These are more important when you are actually handling the data yourself. But I am giving you some clue as to what these colors represent. In this image, you can see a white line. Okay, I think this white line is the dried canal. Is a dried canal, and roads are also linear features, but they are represented as dark lines here. Okay, dark lines here. Okay, so you can appreciate that in this image you can extract the canal, you can extract the roads, you can extract vegetation area, and so on. So these are all problems related to object extraction. Okay, if you have a time series data, you can actually find out, for example, the growth of plants or trees across month. Okay, and in the image at the bottom, you see one region that has been zoomed again and again from 56 meter to 24 meter to 6 meter. So higher the resolution, more is the clarity. But we may not require this kind of resolution if I am doing some kind of a classification strategy for a state. Even this resolution will be sufficient, good enough. Okay, these are images obtained from Cartosat-2. Cartosat is a new series of satellites launched by India. So you can see high-tech city area in Hyderabad obtained from Cartosat-2C. Okay, this is the image from Google, and this is from the ISRO. So the left one is from the ISRO. So you can see that the resolution here is 1 meter. You can see that the clarity in both images are almost equal. I mean, we have reached state of the art. India has reached state of the art in imaging technology or in resolutions. This is the data from Cartosat 3, which was launched in 2019. So you can see the first image is from Google. Okay, this one. The second image here is from Bing Maps. The third image is from Cartosat, that is the Cartosat 3, our new satellite. And the fourth image is from Apple Maps. Many of you may not know, Apple has invested a huge amount of money in GIS, in spatial data analysis. This is the Palm City Garden in Qatar. So you can see that map obtained from Cartosat 3 uh, exceeds in clarity compared to Google, Apple, and Bing Maps. I think Bing Maps is from Microsoft. All these top companies are currently investing a lot of money in the area of GIS, in the area of climate change. They have deployed huge clusters and are working. I mean, with full potential in all these allied areas. Okay, this is a table showing some of the satellites and their images, which are available freely. So we don't have to pay, and we can download the data for our application without any cost involved. Okay, Google has invested huge amount of money. You won't believe Google has actually developed a cloud, and that is called Google Earth Engine. Okay, Google has over has collected over 5 million satellite images over a period of 40 years across the globe, and you do not have to even download the data. The Google Cloud service is free, and it's difficult to imagine their cloud infrastructure. One will be blown up by the amount of computing power and storage they have. They have exceeded several petabytes of storage, and apart from that, they have inbuilt codes, machine learning codes, example in the random forest as support vector machine, etc., in the form of library. You do not have to download any image. Call your image, okay, in your program, and also call the function that you want to run, and the computation will be done in the cloud, and you can see the output in the cloud. So Google has actually done a lot of things in this area, and is a nice place to work. People who are enthusiastic about spatial data and machine learning can definitely think of um, think of joining such large companies. But yeah, getting into these companies is not quite easy. Have done some significant research, or have higher degrees and published papers in some top conferences to ensure that you are the one who is who, for whom Google is looking for. Okay, so Google has a huge repository of satellite data. They have purchased this data, obtained this data from NASA, from European Space Agency, and so on. So this is the old figure. They had 5 petabytes of data, and they're adding more than 4,000 new images every day. Okay, Bhuvan is again something similar to Google Earth, but not exactly same. Bhuvan is a product from ISRO by India. It provides large amount of data related to Indian areas. I mean land. They talk about roads, various socioeconomic features, maps, images, and they have various thematic maps, open data archive. So Bhuvan 3D is also available, just like Google 3D, and for India. This is an in-house homegrown software. Okay, please feel free to visit bhuvan.nrsc.gov.in, the site I have mentioned on the top. Explore Bhuvan more. You will get lot of interesting data to download and to use it for our research purpose in any part of India. Okay, UAV is currently state of the art. Lot of work is happening in the area of UAV. UAVs are mostly used in areas where you need quickly data, and you need data at a very high resolution. So they are being utilized for large number of applications in agriculture, such as precision agriculture, looking at any kind of disease that has spread in agriculture farm, farm productivity, nutrient level of the soil condition, water stress, and so on. They are also currently being used in traffic monitoring, and you might also have seen advertisements of UAV delivering products at home. For example, carrying something from the restaurant and giving it to it at your doorstep. I have already introduced GPS. Many of you might have seen GPS. Many of you use it as part of your smartphone. But there are other professional GPS which are used for navigation and which are used um, for moving from point A to point B, and then they show the routes, and they are also used in GIS for data collection, for defining the route, for defining the shortest path, and so on. Okay, India soon will soon have its own GPS, and it will cover the area all shown by this blue circle. Okay, so we believe that this will be operational by next year. It is called IRNSS, Indian Regional Navigation Satellite System. Okay, and the error will be lesser than meters. So currently work is going on. Hopefully by another 1 year it should be in operational, and then we will be able to avail the service. Now let's see what is spatial pattern. Okay, so there are a lot of problems that happen not only spatially but also with related to time. Those are called spatio-temporal problems. Spatial and also with respect to time, temporal problem. Okay, I have one example. Later on I will show you a spatio-temporal case study. A simple example could be rainfall. So rainfall varies from point to point in a city. Okay, and rainfall also varies from time. So the intensity of rainfall now and the intensity of rainfall after 1 hour will be different, right? So this difference will also vary from location to location. So studying rainfall is a spatio-temporal problem. Okay, there is a very nice example of spatial pattern way back in 1855 when GIS did not exist. Okay, uh, 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 um, one of the areas in London had cholera. Okay, and it was not actually clear from where this particular disease is spreading. Many people, in fact, died. Okay, so then there was a physician, John Snow. He drew a simple map of the roads of the buildings and the location of water pumps. Okay, and then he saw that most of the deaths are happening very close to a water pump. And then he realized that this particular disease is uh, uh, not from the air. Okay, uh, rather not from the particles in the air. Rather, it is from the germs contaminated water that people are consuming from one of the given hand pumps. So as soon as the water supply from that hand pump was closed, the number of deaths started coming down. This was one of the first classical example of simple drawing where people could relate some event caused due to some other event. Okay. Later on, many such examples existed. In 1909, people found that residents who are closer to Colorado River, okay, people who consume water from Colorado River have unusually very healthy teeth. And then they found out that this water from Colorado River has um, has a fluoride, which is actually useful. I mean, which is actually useful for the maintaining the health of teeth. Later on, government decided that let's put fluoride. Let's put fluoride in the drinking water that is supplied to the city. So these are not simply cause and consequence, but these are more correlated events. Okay, and because of this correlation, people are able, or scientists or researchers are able to find out relationship between two events. For example, the occurrence of fluoride and the healthy teeth, and so on. Large amount of GIS has been applied in different domains. If you happen to work in machine learning area, you will be very much familiar with Tidal. Kaggle is actually a website where you have enormous number of machine learning problems along with data to solve. And it is good for beginners, or good for not only beginners, even for experts to participate in these competitions. You can log in, create an account, and see the different types of problems that are being provided in machine learning area. And one such problem is trying to locate the times in different cities. Okay, there is one data related to crime for the San Francisco city, so where people have used predictive analysis and for showing the type of crime in different times of a day and week. And then similar strategy of GIS has been utilized by the police in Chicago, where they have developed heat maps like this, show the type of crime and number of crime held in the neighborhood. Accordingly, they decide the police patrolling and in certain areas. Okay, so in certain areas, depending upon the type of crime and the time when this occurs. Okay, so pattern. So from these few examples, we saw pattern is something which has a frequent arrangement, okay, or configuration or regularity. Pattern has a rule, it has a law, it has a method, okay, and pattern has a direction, a trend and prediction. So therefore, all these examples, and there are many more examples where you have a trend, you can predict something. This is actually a pattern, and there comes the role of pattern analysis and machine intelligence. You derive these patterns using machine learning. Okay, these patterns are non-trivial and they need to be searched automatically. One should not look into every details of the data in a 1 terabyte volume. Your algorithm should be able to automate and look for the right information from this huge data set. This information should be interesting, useful, and they are sometimes unexpected special patterns. Okay, so very interesting studies like where will a phenomena occur? Okay, phenomena can be as simple as a tsunami, or it can be the results of an election, etc. Which special events are predictable? Okay, how can two events? How can one special event be predicted from another special event? Okay, all these points, and we can spend 1 hour to think where we can use these points. Which spatial events are related to each other? Okay, which spatial phenomena depend on other phenomena? For example, there is a there is a heat, okay, in a forest. The heat crosses certain threshold, it may catch forest fire. If there is a forest, so you need to first find out where are the sources of heat, then where will fire occur. If fire occurs, how much area will be affected. There is an accident on a highway, how many lanes will be closed? If lanes are closed for 5 hours, how will people deviate? Which all routes they can take to move away from that point? How will you ease the situation? So there are numerous examples where we can apply these 5 questions and actually solve very interesting problems. Okay, so these problems can be as simple as heat maps, and it can be as good as hotspots. Okay, for example, you in the last 1 year or so, you would have seen numbers of hot maps, hotspots to heat maps about COVID-19 patients, the infections. Certain areas in a city are hotspots of COVID, whereas certain areas have lesser number of infected people. Okay, then we move away from hotspots to neighborhood. So you might have heard the news that a given locality was sealed, was actually sealed. Nobody was allowed to go or come in. Okay, so we move from hotspots to neighborhood, and then we move from neighborhood to a city. Okay, which are the areas in a city that have COVID-19 people? Are these areas close to each other? Are they far away from each other? Okay, so many interesting questions can be answered, and then based on that, right decisions can be taken. You need to seal certain areas infected by COVID-19, not allow anyone to go inside, not allow anyone from inside to come outside. Okay, then let us spread and see which all locality in the entire city are infected. Then move beyond and see which all cities in the country are hotspots of COVID-19. So a few months back, Delhi, Mumbai, Indore, all these cities were hotspots of COVID-19, but slowly the situations have improved. Okay, so association, spatial association, co-location are all similar terms where we try to look at certain phenomena with respect to each other. Okay, for example, here a tree and a fire are correlated. Okay, a bird and a hut are correlated. So this is not very obvious. You may not be able to catch up by just looking at the image, but if you happen to use some algorithm, data mining algorithm, you may be able to see this correlation. Okay, right. So here comes the role of data mining in geospatial analysis. Geospatial analysis, specifically GIS domain, involves data mining algorithms, involves in statistical methods, information retrieval techniques to all geospatial data. Okay, we can also incorporate time, hence it becomes a spatio-temporal problem. So the challenge is how do you integrate data from all these sources in one database, and then how do you perform the mining? How do you perform the mining? So how do you drill down across layers of information to retrieve something interesting that is of importance? Okay. Spatial computing is an allied area, and there are many examples where spatial computing has touched life of billions of people. Okay, for example, when you use the Google Map, okay, you are interested in you are interested in moving from point A to point B. You look for the shortest route. Now people have moved away from shortest route. They want to look for the greener route, ecological route, the green corridor, okay, and so on. So are there ways to compute this? Most of you have used GPS to locate yourself, and hence there are a number of applications using location based services. Okay, probably you look for Italian restaurants close to me or restaurants near me. Okay, or you may use Yelp advisor if you want to locate one of your best places to eat. Okay, or you may have seen Google Earth. Google Earth is a nice platform to explore places. Okay, if you want to look for an apartment, you use common floor. Okay, you give your location, and then it will show you maps like this, saying these are the houses which are available for rent. People use 99 acres, Zillow, Tulia. These are sites which will give you houses available for rent in a given budget. Okay, then you have, all of us have used Uber, Ola, Ride. All are these are examples of location based services. Okay, their location based services are being used in so many applications in day-to-day life. Spatial computing are now being used in many applications. For example, in looking at the world biodiversity, in controlling the crime, in precision agriculture, in tracking endangered species, okay, in site selection, logistics, in public safety, and so on. So you would actually see that there are so many areas where people are using GIS and spatial computing. Okay, and machine learning, the term machine learning is often used now, where people learn from the data. Okay, where people learn from the data to define precisely a class of problems. Okay, that encompass interesting forms of learning. People explore algorithms to solve problems. For example, trying to develop a smart house that learns by itself how much power will be consumed, and which are the places that need to be heated up, and so on. Okay, all of us have seen examples of autonomous vehicle. So these are all trained using machine learning algorithm. More specifically, they are using deep learning. So these cars are trained to move on the road, to navigate on the road, at the same time follow the traffic rules. This is an example of a output of a clustering algorithm. Clustering is a kind of machine learning algorithm which shows the number of Facebook account holders across the globe. Okay, perhaps this map was not easy to derive if you use any statistical method, but with machine learning it has become easy. You can show the density of number of users, which is approximately more than 10 million across the globe. Okay, you when you get up in the morning, your personal assistant, maybe your mobile phone, for example, your Siri or OK Google, okay, Google Assistant, and so on. They show you the news. Okay, so they show you the news based on what you like. The news can be grouped like entertainment, politics, sports. If you enjoy sports, you only sports news will be shown to you. Others may be at the bottom. Okay, so there are certain points in perspectives in machine learning that one has to think of. Okay, so there is a concept of hypothesis space. Okay, and essentially when you work on machine learning problems, you look to find out a solution in that hypothesis space which has some underlying representation. Okay, people use linear functions, logical description, decision tree, artificial neural networks, and so on. Okay, then now when you talk about machine learning, think of learning as a search problem. Think of learning as a search problem. Okay, so here we need to consider size of hypothesis is to be searched. Okay, hypothesis is a term which comes from statistics. Therefore, in the beginning I said that underlying principle behind machine learning algorithm is lot of mathematics in the form of statistics, probability, linear algebra, and so on. Okay, machine learning problems depends on number of training examples. Okay, and then confidence that a hypothesis is consistent with the training data. Okay, so there are a few design choices. For example, which is the best algorithm to use for what is the target function that you will use, which is the algorithm that you will use in application. Okay, so the term learning in machine learning involves search through a space of possible hypotheses to find the one that best fits the available training data. Okay, and this particular example shows you the steps involved in machine learning. You have a learning algorithm that will learn through your training features or training levels, and then you develop a model and then test the model on a data and then infer something. Once you have inferred, we evaluate the algorithm using some accuracy measures. Okay, I'm going to show you one very simple case study in 2 minutes before closing the talk. So we did one simple study of the city of Bangalore to see how the growth has taken place across the region. All of us know that because of the large foreign direct investment, a lot of multinational companies have settled in and around the region. Okay, and we wanted to capture how this growth in the city have taken place. So new airport has come up in this region. Actually, the new airport now also has Terminal 2 ready for international flights. In the eastern region, the city has grown. City has grown towards NH4, that is the Bangalore-Pune highway. In the western side, city has almost crossed Hoskote. In the southern side, new areas like Electronic City and Atibele, etc., are now the places where a lot of constructions are happening. So this is the city of Bangalore. The red color here is the settlement, the buildings. Okay, so we see that in this image, there are only few settlements in the center of the city, shown as red color. All the blue pixels here are your lakes. Bangalore actually used to be called City of Lakes and City of Gardens. So all the green areas are your vegetation. Okay, pink areas are your others, not others I mean open area, some vacant land, etc. So our focus is on the red pixels. Okay, see the quantity of red pixels, the number of red pixels have grown in 92. Okay, now you see that city has grown in 2000, in 2004, in 2009, in 2014, in 2018. So now look at the city growth. This is the development in and around NH4. Okay, this is the electronic city area. This is the I think Kanakpura road. This is the old Madras road. Okay, this is the new airport and developments around the airport. So this is a trendy question. How has the city changed over a period of time? Okay, how do you visualize this kind of data? There comes the role of computer vision. So we have represented the development in each span of time using a different color, and each color represents the changes happening in that year. Okay, so what is the trendy question here is, the trendy question here is that the city has grown by 1794 percentage in the last 40 years. Okay, the amount of vegetation has come down from come down by 66.5%. Okay, and there has been a decrease in number of lakes or water bodies by 3.22%. Okay, these graphs tell you the entire story. The urban areas, the red pixels have grown, water bodies and green vegetation has come down. Okay, this is what if question. What question? What exists at a given location? How has it changed? And what has been a spatio-temporal pattern? And these all derived images, classified images, are as a result of machine learning algorithm. Large-scale projects can be thought of: climate change, global vegetation biomass. Okay, mapping the region in droughts, monitoring global droughts, climate downscaling, typical rainforest measurement missions. So there are so many projects going globally using a large number of machine learning, scalable machine learning algorithms. Okay, there are certain challenges and research opportunities. Challenges are that people do not share data. Therefore, we keep on downloading and generating the same data again and again, and that leads to redundancy in storage, and also cost over budgets. Okay, downloading, uploading data is slightly time consuming, and therefore it is slightly expensive. And people have not yet realized the benefits of sharing codes, results, workflows, and they tend to keep it secret. So that is why we also do the same thing again and again, because results are not shared. So we must move away from this. So we should move towards a collaborative movement in development of machine learning algorithms, scalable processing, multi-resolution, handling multi-resolution data, deep learning, and so on. Um, okay, so and we must now try to focus on open source softwares and promote the free and open source um, uh, mission. So what lies ahead for machine learning? The recent trend, state of the art, are convolutional neural network CNN, and then faster CNN, RCNN, YOLO. YOLO 3 is currently the latest for image segmentation, UNet, SegNet, SPNet. Facebook has released a few algorithm through Facebook AI research, and that is called FAIR algorithm. Okay, and then there are large number of applications in remote sensing that can be thought of while utilizing state-of-the-art machine learning problems. Okay, so I would like to end my talk, and there are large number of problems which we need to address through spatio-temporal analysis, through machine learning algorithms, from water scarcity to flood management to deforestation and so on. And one has to actually work closely and provide solution to the government, to the stakeholders, through the right application of machine learning algorithms. Okay, I will just summarize what I have talked about today. So I introduced you to GIS and spatial data. We talked about remote sensing. We talked about spatial data analysis, and then we saw some case studies and then the challenges and applications in this allied area. Okay, so I acknowledge all the people from whom I have been continuously being motivated and who have taught me in different points of time. And with this, I would like to conclude my talk. And thank you all of you for being attentive for last 1 hour 26 minutes, 1 hour 27 minutes, and um, I welcome you to ask any questions to me at this point of time.
Doctor, thank you very much for
Thank you so much.
thank you very much for a very nice talk on geoinformatics, its applications, and also opportunities in the field of geoinformatics. Participants, any questions? Hello? 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 Any questions, participants? Dr. Uttam Kumar? Hello?
Yeah, please. Yes, sir. Yeah, I'm
Thank you,
available.
sir, for a wonderful talk. If there are any questions, we'll forward it to you. We can
Definitely. Yeah,
um,
sure.
thank you very much. Very kind of you for accepting all of our invitations, and
Definitely, sir. Yeah.
yeah, we'll be inviting you again for offline physical meets, and we are very grateful to you for a wonderful talk. I'm sure students would have got very good take-home messages on how geoinformatics is useful in our day-to-day activities. We are grateful to you, Doctor. Thank you very much.
Thank you, sir. Thank you so much.
Now let us start the second session. We have with us Shri Srinidhi. I'm sure some of you would know him. He is a very good science communicator. He has been awarded many prizes for his excellence in science communication. Welcome, Dr. Srinidhi.
Good afternoon, sir. Thank you very much.
Now let me have the privilege of introducing Srinidhi to all the participants. Srinidhi has 16 years of experience in the field of IT and is working as a senior manager at a global consumer electronics company. In his current role, he is responsible for the India team working on data and analytics. Srinidhi has a bachelor's degree from most prestigious SJC Engineering College, and he has also obtained MS from another prestigious institute, BITS Pilani, when he is a certified project management professional. Srinidhi, as I told, he has also won prizes for his excellence in science communication in Canada. Indeed, KSTA has Best Science Communicator Award in 2012 or 13. And with this background, may I request Srinidhi to take over and deliver his talk. Over to you, Srinidhi.
Thank you, sir. I'm sharing my screen. Please let me know when you can see it.
Yes, sir, it's visible, sir.
Thank you very much. So first of all, I thank Karnataka Science and Technology Academy for this opportunity given to me. Like Dr. Ramesh said, I am interested in science communication, and one of my recent interests has been to try out teaching. That's one of my long-term goals, to kind of interact with students and share whatever I know and learn from them as well. This, I believe, is a very good opportunity. I don't know for the audience, but for me, I believe this is a really good opportunity. Thank you, KSTA team, for giving me this opportunity. In alignment with the topic for today's and the current session, which is going on for the past 3 days, I'm going to talk about the recent advances in career opportunities in data and analytics. Why data and analytics? Like Dr. Ramesh said, I have been working in this area for more than 10 years now, and I believe I have some points that I can share with the aspiring professionals who want to build a career in this area. So what is the agenda for this discussion? So we'll see why is data important, what are the opportunities that the field of data presents us, and what is the road ahead? How does it look like? How does the future look like in terms of data and analytics? So I'm sure a lot of us would have started with a basic computer science background, right? We would have started with some fundamentals of computers. So I have put a picture of a book over here, which is probably something we would have all read. If not the same book, something similar we would have read when we started to learn about computers. So such books generally spoke about what is a computer. And then probably the next question that we would have all read is, what is data? To put in simple words, data can be text, data can be numbers, you could write data on papers, you could write it in a book and keep it somewhere, or it could be bits and bytes that reside in the memory of a phone or a computer or anything, right? Any electronic device. Or it could even be what we have inside our mind. We are thinking about what do we do in the weekend. We are thinking about what do I do in the meeting this evening. We are thinking about, okay, where do I go for breakfast tomorrow morning? And so all these things put together are called as data. Then we know that computers process data and they help us make sense out of all this data which is lying around. If we look at it, right? If we look at the concept of data, everything around us is data, right? If we are talking about rain, how much of rain has Bangalore got in the past X number of days? If we are talking about pollution, what is the air quality level in Bangalore? If we are talking about anything for that matter, if we are talking about newspaper, how many copies of newspaper are produced, how many newspapers come to our house, how many pages does a newspaper have, how many advertisements does a newspaper have, and how many pamphlets that have come with a newspaper. If you just look at it, everything, printed, physical, digital, a lot of different forms of data always surrounds us. Now, when data is so abundant all around us, why are we really bothered about data so much? And why are we even talking about data specifically in a webinar like this? Here I have a screenshot of an article which was published, I suppose, about 3 or 4 years ago in The Economist. So this article, I would leave out the details for you to go and search or read on the internet. This is available on the internet. So let's just focus on the headline or the title of this article. It says, the world's most valuable resource is no longer oil, but data. How can we relate it? How do we make sure that we understand what they're talking about, right? This actually is an article talking about the internet giants. So if you look at a lot of these companies, right? If you look at a lot of these companies, they have nothing but data as their assets. A huge search engine works on data. All the aggregation companies work based on data. All the social media websites work based on data. So if such a big industry itself can be built, so then, yeah, I think we kind of agree that data is very valuable. So in the olden days, people would say, okay, gold is the valuable resource, and then oil became the valuable resource because it kind of drove everything across the world. then we can actually ask another question. How come data is the most valuable resource? Or how do you even say data is the new oil? Let's just look at the petroleum process, right? So there is oil that is extracted from the oil wells. It's extracted from deep inside the inside earth. We'll extract it, but oil does not help until it is actually processed and it becomes, let's say, the fuel for an airplane, the fuel for our cars and bikes, or even the fuel for, let's say, the stove in the kitchen. Only then the real value of oil is visible to us. Similarly, data might be the most valuable resource at this time, but how does data help? So this is a quote. This is rather a lengthy quote from a person called Clive Humby that I've quoted here, and I've highlighted a few points that I found were interesting. So what he says is data is the new oil. It is valuable, but if unrefined, it cannot really be used. So similarly, right, the oil, we say that oil comes out of the oil well. Can you put that into your car? No, you cannot. Until it is refined, processed, and lots of things happen to it, it's not really useful to us. Similarly, in data, it has to be changed like oil, how it is changed to gas, plastic, chemicals, etc., to create a valuable entity that drives profitable activity. So must data be broken down, analyzed for it to have value. Now we are talking about the focus for this presentation. So we know that there is a lot of data. We know there is a lot of data all around us in different shapes, forms, and sizes. And we also know that people are saying that data is the most valuable resource of our age. But data's value to be extracted, it has to be broken down and analyzed. What does that mean? What do you mean when you say that you analyze data? And how do you extract value out of data? This has given way to a huge section in the information technology world that is called as data and analytics. Here on the screen, I have a definition taken from Gartner. Gartner is one of the largest research and advisory companies in the world. So what they say is, you can actually even focus on only the highlighted words, but let me read this out. Data and analytics is the management of data for all uses, operational and analytical, and the analysis of data to drive business processes and improve business outcomes. So, a lot of things that happen in the current world are driven by data. And by doing that, we also improve business outcomes. How is that? I mean, how is that done? Through more effective decision making and enhanced customer experiences. So, effective decision making. We have seen the COVID pandemic. We have been probably the witness to a extremely weird phase of history where we have seen a lot of unimaginable stuff over the past year or so. If you look at that as well, to analyze, I think there were sessions on data science before in day one, and I think today also there was an earlier session. So if you have looked at the examples covered in those sessions, you would probably have understood how decision making was enabled by data science, how machines helped humans take decisions, how a certain decision making was made, more effective by using all these tools. Look into a little more detail, we see all of these is driven by data. And the second part, let's look at a simpler example, right? You are shopping on an online site, and then you are looking for two things, and then you are even thinking of a third thing to buy, and in all likelihood, the website itself shows that you might be interested in a certain stuff, and you'll probably find your third thing over there. That is an enhanced customer experience because it is actually suggesting you what can be bought without you having to make any additional efforts. So this is one example of enhanced customer experience, and such enhancements in the customer experience can be brought in by effectively using data and analytics. And what does this do? Effective decision making and enhanced customer experiences is possible by data and analytics, and that drives business processes and improves business outcomes. Companies do well. We have good outcomes even when, let's say, a data-based decision is taken. And then overall, we have the value coming out of that data. That is what is the field of data and analytics. And that is how, and that is why we have a lot of focus all across the world in this area right now. But when we are talking about data and analytics, I presume most of you are students of engineering, you would definitely have heard a whole big bunch of terms. You would have heard cloud, you would have heard data warehouse, you would have heard analytics, you would have heard data science, you would have heard data engineering, visualization, business intelligence, a lot of stuff, right? For us to even consider a career in the field of data and analytics, we can actually try to understand some of these things and see how it all makes sense in the larger picture. So let's look at some of the things that we see when we talk about data and analytics. If you read any data and analytics article, magazine, watch a video, I'm sure there would be some of these terms that would be coming up during your research or during when you're reading something about data and analytics. In engineering, if I remember right, VTU has, I think, big data in some of the semesters, and I think there is data warehouse and data mining covered somewhere, and of course you will have excuse me, and of course you will also probably have the fundamentals of databases pretty much starting from the first semester itself, I guess. So you hear a lot of terms. What are all these terms? You hear about analytics, you hear about big data, you hear about business intelligence, you hear about data governance, data mining, data quality, data science, visualization, master data management, DevOps, data ops, database design, data warehouse, and so on. So for understanding all these, I'm sure you know a lot of these already by either from your self-study or from your syllabus. We have to, as a first step towards getting into the field of data and analytics, it will be really good if you can see what these terms mean. And if you can go to a reliable source and just start reading up, just understand what these terms mean. Let's take one as an example, right? Let's look at data warehouse. Data warehouse, like its name suggests, it is a warehouse of data, like how we have all our e-commerce companies warehouses for their products. Data is a product in the warehouse and it is stored there. So why should data be stored in a warehouse? Let's consider a large company which has been in the business for 20 years. So a lot of its decision making would be really more effective if it can learn from what happened in the past 20 years. Similarly, based on what happened in the past 20 years, the company can also try to predict what could happen in the next 5, 10, 20 years. And also, for them to take any decision, they can always rely on the old data to see what was happening, what is happening right now, how was the sales last month, how was the sales 1 year before this. If you look at the general releases that come in, the results, financial results that come in any of the newspapers, you already see some of these things, right? It says, okay, this company made X percentage of profit for this quarter, whereas the profit for the same quarter in the previous year was either more than X% more than this one or X% less than that one. And similarly, it can give a lot of inputs to the investors, it can give a lot of inputs to the government, it can give a lot of inputs to the regulators as well. And for an investor, this data also helps. So that is how we see for the company to, let's say, make profit, it can use data, it can rely on the old data. Once the company makes profit, the investor can rely on that data to take a decision. The company would have taken decision that would have led to its profit or loss based on some data. And similarly, the investor is taking the action based on the data. And also, let's say, the governing agencies, the governments and the income tax departments or somebody else will also be handling a lot of data. And all of those data, historical data generally, would be staying in some or the other data warehouse. So what are the other things then? What is master data, for example? Master data is data about data. So you are, master data is about the central data repository for any company. So let's say a company is dealing with 100 customers, and those customers' data can be considered as master data because you keep the customer data in one side and everybody in the company uses the same data. So master data management is dealing with that kind of data. So then we have to also figure out how do you govern all these data? How do you govern the data which resides inside a company that gets into the field of data governance? Similarly, you want to do the old style reporting where you want to get the data out and have somebody look at it and make some sense out of it. That's called business intelligence. You want to create graphs and you want to create dashboards and you want to tell a story out of the data that you have. That is called visualization. So why am I jumping from one topic to another, and why am I having this slide which looks very clumsy, right? The reason for that is the field of data and analytics, I just wanted to highlight, is very vast, and everybody has an opportunity irrespective of what their primary skill is. So let's say for somebody to be active in data science, they have to be strong in mathematics, they should have background in statistics and so on. Right? Let's say we have one of our friends who is very creative, who wants to use graphics, who wants to create something using different colors and tell a story using all the graphs and stuff that he can build. He can get into visualization. Similarly, somebody wants to explore their database knowledge. They could design the databases for a data warehouse. They could design the processes for the data warehouse. They could build the ETL for the data warehouse. They could help the data scientists get data out of data warehouse and make sense out of it. Therefore, we can definitely look at data and analytics, not just as, let's say, okay, it is boring because it's DBMS, or saying that, okay, it's high paying because it's data science. There are a lot of things beyond what we see on the face of it. And that is why I believe data and analytics would be an interesting field for most of us. So when we are talking about data and analytics field, we hear a lot of opportunities. One, of course, is in the field of data science. It's one of the hot and happening areas of recent times. So everybody talks about a data scientist. But then you might have also heard about other roles. There is a data analyst, there is a data engineer, there is a data visualization developer, and so on, right? Let's try to understand what is the difference, or how do these roles relate to each other. So for that, let's forget about the names and the designations and think about the overall flow of data. Let's take a company which sells chocolates. So what are the different things that happens in that company? One side, the chocolate needs to be manufactured. They have to source the ingredients. They have to make sure that their supply chain is consistent with their demand. So they need to find out what is the demand and how much they should manufacture, how much they should have in stock, how they package it, how they send it, and to which areas do they send it, how do they send it, do they send it in a truck, do they send it in a refrigerated van, do they just ship it, send a courier to some place? That is another thing. And then there is a second part where they need to sell those chocolates and collect information on how the chocolates are doing in the market. Let's say the chocolate company is selling 10 different varieties of chocolates in 4 different zones of India, and each zone they need to track how much money is coming in from each zone, which zone is doing better, where are they selling what kind of chocolates more, and which kind of chocolates probably are not selling, and what probably is the demand for the next month. And this cycle repeats. And at each step of this cycle, there is a lot of data that is generated. Right from the demand, sales data can drive an estimate of the demand, saying that, okay, the sales has been like this, historically the sales has been like this, and based on that data, let's say we will manufacture this much of quantity of chocolates for the next 3 months. And then we'll also probably have to say that, okay, at this rate, we are making this much of profit, and then if we have to sustain, we can either increase the rates, or if we are really doing good, we can increase some offers based on what we have heard back from stores. Now, when we are dealing with a lot of this kind of data, the first step is to acquire all the data and put it in a place which is helpful for further processing. The data engineer comes into picture there. The data engineer makes sure that the data acquisition happens from the source. The data is acquired and put in a place where the enterprise-wide users, from the, let's say, the shop floor operator till the CXOs of the company, they'll be able to access it. So data engineer has a very important role in making sure the data gets into one of the systems and stays there. And then next thing would be, somebody would like to get the data. There would be a sales manager who wants to see how the sales are going on. So there are 2 things that are possible. One, the person himself knows how to do it, and then they will access, let's say, the self-service model. For that self-service model, there will be more people who would be working on enabling that self-service model, so that the sales manager can go and extract the data. But a senior manager, for example, might not have the time or the interest to get specific details about each store, right? There are 2,000 stores in a region, and he would just want to see how did our region do. Then you could have some sort of visualization built on top of it. You could create a nice mobile app for him where he can log in and he can just see, okay, what is the sales for in my region for the past 3 months. He could also probably compare his sales with other sales or the overall sale. How much of sales from my region is contributing to the overall sale of the company. This one, telling stories to even non-technical people, is the responsibility of a data visualization developer. Those guys actually understand the data and think like a user what can make sense with the help of user experience designers and then the graphic designers, and then the visualization can be built. Then there will be some more sort of analysis that needs to be done, let's say to file to a regulator, or we have to do very complicated calculations and analyze the data and report it out to different audience. Data analysts do that job. And then based on all the data that we have, we could try to find patterns, we could try to build models on top of it, and then see how that would help us in future. That is the responsibility of a data scientist. So now, even though I have only 3 images and roles on the screen, we have already talked about 5, 6 positions. Similarly, within these areas itself, we have a lot more areas that are important in data and analytics. So we talked about master data. I took the example of customer data, for example. Customer data can be maintained at one place in the company, whereas it can be used across the company by different users. Data governance also we spoke about. Application development. When we are talking about data warehouses or even capturing the data, it is not always possible to go with a standard tool or a platform. Sometimes what happens is there is a very important data set that might be coming from a small user group, and they are probably using an Excel to keep track of whatever important data that they manage. So what if we want to make their life easy and build an application to enable getting that data and probably merging that data with everything else that the company has, so that the value of that data is enhanced. There, the application developers come into picture. It is not like if you are in the field of data and analytics, it is not like you don't get at all to do any app development or a software development, right? Yes, of course, there will be a lot of backend work, there will be a lot of configuration work, but application development is also definitely there. Data visualization is another area we just spoke about. Then a lot of people are developing a lot of different things, and that all needs to be deployed. Now you might have heard of the different project management methodologies, how the life cycle of a project is managed. So earlier we used to have the waterfall method, and now we have agile methodology where everything is done quickly in cycles, and then what are called as sprints, and then we keep on delivering stuff at shorter intervals. How do you make sure that those deliveries get into the actual system and be available to the users? How do you do continuous integration and continuous deployment? DevOps engineering talks about that. And even before that, if you're talking about how you build your database to store all this data modeling talks about that. Data engineering, we already saw how data engineers help get the data from its source and make it available for the consumers of that data, be it data scientists, be it the end users, in a way, form, and shape that is most useful to them. So we have covered most of the areas, different samples that are in this slide. Now we need to talk about cloud. Whenever databases were mentioned in the past, it was like a server would be there somewhere, then there would be a database administrator, and then he would do a lot of work in terms of upgrading the database and keeping the database in a proper form, and then doing the backups and all that stuff. There would be a lot of work for a database administrator. Now, with everything else moving on to the cloud, a lot of data insights and analytics sort of work has gone into the cloud. So you would definitely have heard Azure, you would have heard Google Cloud, you would have heard AWS. Almost all the cloud platforms have something or the other to support data and analytics. So this way, we again are just reiterating here in the field of data and analytics. And if you are, let's say, thinking only about SQL, or if you're thinking only about application development, or if you're thinking only about data science, there is still a lot that you can do in a lot of different areas as well. So how do we do it? Let's get into the actuals, how do we do it sort of thing, right? One simple formula for doing anything that we like, anything that is challenging, is learn, unlearn, and relearn. What does that mean? Let's take an example. Long time ago, every document had to be written, right? Every document had to be written, and it was a difficult task to probably have a good handwriting, or if you need copies, write multiple copies, and so on. Then somebody invented a typewriter. Typewriter kind of standardized the fonts or the way in which the text would look. And also, if you use, let's say, carbon paper or a cyclostyle machine, you could print out a much larger number of copies compared to how much you would have written usually. So that kind of gave a lot of opportunity to people to learn, right? People who were writing, some of them started learning typewriting. Can we end there saying, okay, yesterday I was writing, today I'm typewriting, and it's definitely better than yesterday, so can I stop? We cannot stop, because tomorrow a computer came. Yesterday was paper, today is typewriter, tomorrow a computer. And the computer came, the opportunities became much larger. Computer could create the data, you could copy paste the data, you could edit the data, you could make the data look neat on a paper, and you could print it out, you can send it to somebody without even printing it out. So there came the question of unlearning. Instead of saying that, okay, I know typewriting, now it's time to unlearn typewriting. Forget about typewriting, now start learning computers, right? So that is the relearn part. So from writing, we learn typewriting, and then we unlearn typewriting, and then we relearn. This is not just relevant only for this particular area of data and analytics. It's probably applicable everywhere, right? So take let's say Kodak as an example, right? They were the pioneers of photography. They tried to do digital photography, but they were like, okay, who cares? This is not really a good thing. So they did not do the unlearn. They were still stuck to their photo films and stuff. Now, if you see, Kodak is pretty much nowhere in the picture, right? Similarly, to be relevant in the field of information technology, whatever be your focus, you might want to do data analytics, you might want to do aerospace, you might want to do software quality, you might want to do pretty much anything in this whole world. Learn, unlearn, and relearn could definitely help you to stay relevant in whatever you're doing. So how do we get started? I found this interesting quote, supposedly by Walt Disney. Simple. The way to get started is to quit talking and begin doing. So, okay, we want to begin doing. What do we do? Some examples I put here. This is not definitely an exhaustive list. This is some examples that you could probably pursue. Instead of going into the specific topics over here, I would like to give a little more emphasis on doing something outside of the syllabus. Right? Let's say tomorrow you are trying to approach a company as an intern, as a fresher engineer, or you're trying to get into a startup, you're trying to build something of your own. Every time, something that differentiates you from the crowd definitely helps. So if 100 people in your class are reading everything that is there in the syllabus, you also focus on something else which is not really a part of your curriculum. So what could that be? So database fundamentals and SQL would be in your curriculum. ETL basics probably will also be in the theoretical part in your data warehousing subject, but try to learn what is ETL and what tools are there in the market right now. Just read about it. And another good thing is, being students, lot of the tools which are otherwise heavily expensive are given free of cost. So take example of some visualization tools. Let's say Tableau or Power BI or Power Apps sort of stuff. They are generally very given at a very low cost for students, or they're free of cost for students. Similarly, you would have learned some programming language, focus on application development, build something, be a creator, build something, and then try to learn about the fundamentals of DevOps, fundamentals of cloud platforms. When coming into platforms, there are a lot of tools that need to be managed. For example, Tableau, being a visualization tool, has an administration side to it. Any of the big data platforms has an administration side to it. Any of the cloud platforms has an administration side to it. So you think about those things, just learn about that. You may not really have the use case to do something on your own, but learning is definitely helpful. With all the MOOC courses that are available right now, and also the affordable online platforms that are there, it is really helpful to read some of these stuff up. Or if you're interested in something else, it applies to that also. Whatever you're interested in, read some of this, keep yourself up to date on what's happening outside of your curriculum, college curriculum as well. And that would definitely set you apart from the crowd when you are really interacting with the outside world. Few more, I think we are almost, I mean, we have about 10 minutes or 15 minutes left. So I would like to give some more inputs on how we can be prepared. First thing applies to everything is staying curious. What is happening in the world of technology? Well, this guy is talking so much about data and analytics. What is data and analytics? Which are the good websites or good resources that can tell me about data and analytics? At the same time, focus on fundamentals. I know a lot of people are interested in machine learning. I know a lot of people are interested in artificial intelligence. At the same time, it's definitely good to focus on all of that, but focus on fundamentals. Have your fundamentals strong. Master the art of programming. Programming not just helps creating software, it also helps think like a computer, build that computational thinking, and improve your problem solving skills. So the one final thing is not to limit your options, right? You may think that, okay, everybody is talking about machine learning, everybody is talking about data science, everybody is talking about something else. So don't let everybody influence you. You don't limit your options, explore a few things, keep learning, and then you'll be in a position to take your own decision. So that is that's where they say, right? Change is the only constant. Things keep on changing. What is hot and happening today might be a thing of the past in 3 months down the line. So we can keep ourselves up to date, specifically when it comes to this kind of things in data analytics. So this is one example I put on the left. This is a top 10 trends. Gartner generally produces this thing every year. So if you look at it, you can get a lot of insights on what is going on. So this, again, going back to the fact that we should read a lot, you can actually look at such resources to get inputs in terms of what you want to learn, how do you want to shape your career, and so on. And then not to really deviate from this fact that artificial intelligence is changing a lot of stuff. And this is not just doing automation or stuff like that. It is also creating a lot of opportunities for us. Like, I think this was Sundar Pichai. AI is one of the most profound things we are working on as humanity. It is more profound than fire or electricity. We'll be seeing a lot of change in the future because of AI and disruptive technologies like that. And by being active, by being curious, by being in the learning mode, we can definitely learn a lot and create a lot of opportunities for us. With that, I conclude my presentation. I wish you the very best, and we can take questions if you have any now. My contact details are on the screen right now. You can note it down and connect with me even offline.
Thank you very much for very informative talk, Mr. Srinidhi. It was really a wonderful talk. Participants, any questions? If you have questions, please share in the chat box. Srinidhi, as of now, there are no questions. If any of the participants post them, we'll redirect to you. You may answer on that. Okay?
Sure, sir. Sure, sir. Yep.
Once again, on behalf of KSTA and all the participants, thank you immensely for your time and good presentation. We'll be inviting you for our future workshops and conferences. Thank you. Thank you.
Thanks a lot, sir. Thank you.